Dear students, how are you all? Hope you are all fine by the grace of God. He has been good to all of us. Let's continue to trust in His goodness. Are you ready to learn? Let's continue to learn rational numbers. Maybe you have some doubts, don't worry. I'll clear all your doubts. Do you remember what you learned in the last class? Let me briefly explain what we learned in the last class, okay? First, we learned closure property of multiplication for rational number. Do you know? Do you remember what is closure property? So I'm not going to explain. Just if you have any doubt, you can go back and click day 2, then you can learn more about that. Secondly, we learned commutativity, commutative property. What is commutative property? Do you remember? I hope that you remember well. Alright. Then we learned associativity, associative property. Then next, multiplicative identity. Which is the multiplicative identity? 1 is the multiplicative identity. Okay. And then finally we learned multiplicative inverse. Okay, every rational number has a multiplicative inverse. This is all what we learned in the last class. Today we are going to learn the subtraction of rational numbers. Okay, first class we learned the addition of rational numbers, and this is day 2 we learned multiplication of rational number. Today we are going to learn subtraction of rational numbers. Okay, so there are mainly 3 properties for subtraction of rational numbers. Students, let us learn first closure property for subtraction. So let's observe the following examples. First of all, let's take the difference of 2 rational numbers, 1 by 3 and 3 by 2. Let's take the difference, that is 1 by 3 minus 3 by 2. Here denominators are different. Denominators are 3 and 2. So when the denominators are different, we have to take the LCM. LCM of the denominators, it is 6. Then on solving, the numerators will get 2 minus 9, which is minus 7 by 6. Now look, minus 7 by 6 is again a rational number. Okay, let's see another example. Here also we are going to take the difference of 2 rational numbers. So the rational numbers are 2 by 3 and 4 by 5. What are we going to do? We are going to take the difference. We are going to subtract one rational number from the other. Okay, that is equal to, here 3 denominator 3, here the denominator is 5, so denominators are different, so we have to take the LCM. LCM is nothing but 15. Now here 3 5s are 15, so 5 2s are 10, here 3 5s are 15, 4 3s are 12. 10 minus 12, which is minus 2 by 15, which is also a rational number. What is the conclusion? That means every time you subtract 2 rational numbers, the result will always be a rational number. This is what is called a closure property for subtraction for rational number. That means if you take the difference of 2 rational numbers, the difference, or you can say the result, will also be a rational number. So we can conclude operation of subtraction on the set of rational numbers is closed. Is it clear? What does it mean? It means that every time you take the difference of 2 rational numbers, the result will also be a rational number. Okay, it's clear. Now students, we are going to check the associative property for associative property of subtraction for rational numbers. You remember, when for addition commutative property is valid, okay, that means you can add any two rational numbers in any order, the result will be the same. Now let's see the same property in case of subtraction. Okay, so let's learn it with the help of an example. See here, what I'm going to do is I'm going to take the difference of two rational numbers. What are they? They are 1 by 7 and 1 by 5. Let's take the difference. That means now I am subtracting 1 by 5 from 1 by 7. Look here, 1 by 7 minus 1 by 5. So the LCM is 35. Now on solving, you'll get the numerator 5 minus 7, which is minus 2 by 35. Okay. Now I'm going to change the position of the rational numbers. Okay. Earlier it was 1 by 7 minus 1 by 5. Now what are we going to do? We are going to change the position of the rational numbers. Let's say that 1 by 5 comes first. So 1 by 5 minus 1 by 7. That means I'm subtracting 1 by 7 from 1 by 5. So the difference is, the denominator is 35. The numerator we get 7 minus 5. The result is 2 by 35. Now look at the results. In case 1, the result is minus 2 by 35. Whereas in case 2, the result is 2 by 35. Look, case 1 minus 2 by 35. Case 2 plus 2 by 35. Are they same? No. The answers are different. What does it mean? That means order is important in the case of subtraction. We cannot subtract. We cannot change the position of the rational numbers. Okay? What is the conclusion? That means the operation of rational numbers, operation of subtraction for the rational numbers is not commutative. Okay? Students, next we are going to learn associativity when there is subtraction. Okay, what are we going to do? We are going to verify associativity or associative property when there is subtraction. Alright, for that we have to consider three rational numbers. I am going to take here three rational numbers which are 1 by 7, 1 by 3 and 1 by 5. So I am going to take the difference of first and second, and then I'll subtract 1 by 5 from the result 1 by 7 minus 1 by 3. Okay, let's do the calculation inside the first bracket. Okay, we'll do 1 by 7 minus 1 by 3. So here the denominators are 7 and 3, and their LCM is 21. While solving, the numerator will be 3 minus 7. Okay, so minus the third rational number will be written as it is, that is 1 by 5. Again 3 minus 7, which is minus 4 by 21 minus 1 by 5. We'll take the difference. Here the denominator is 21. Here the denominator is 5. Okay. Then the LCM of the denominators, LCM of 21 and 5, which is 105. On solving, in the numerator will get minus 20 minus 21, that is equal to minus 41 by 105. So this is the result. What we are going to do is, next we will be doing the same operation, whereas the order will be a little bit changed. Okay, so we're going to take the difference, changing the order. So we'll group second and third number, okay, in the bracket, that is equal to 1 by 7. First expression, our first rational number will be the same, that is 1 by 7 minus 1 by 3 minus 1 by 5. Let's take the LCM 3, 5, LCM is 50, numerator will be 5 minus 3, that is equal to 1 by 7 minus 2 by 15. Again the denominators 7, 15, the LCM is 105, numerator will be 15 minus 14, that is equal to 1 by 105. Let us check the result. In case 1, the result was minus 41 by 105. In case 2, the result is 1 by 105. That means the results are different. That means order is important. These two expressions are entirely different. So what is the conclusion? Subtraction is not associative for rational numbers. Students, I have included a beautiful diagram for you to understand the concept of natural numbers, whole numbers, integers and rational numbers. Look at the diagram carefully. How many circles are there? There are 4 circles. The smallest circle represents the set of natural numbers. Then you have the set of whole numbers. The set of whole numbers contains 0 in addition to the numbers of the set natural numbers. Then you have integers, and the biggest circle represents the set of rational numbers. Okay, I think this picture will make you understand the concept of natural numbers, whole numbers, integers and rational numbers.